Here are the solutions to the study guide. Shout out to Miss Perez's class who asked and asked for this video, who came over in person, and I'm a softie, and I'm glad you find value in it. So here's your study guide. I really hope this means you do well on the exam that you're taking, and I kind of know it will help you on that exam. You're going to do good. All right, let's do this. Now, you know and I know that if you just follow what I'm doing and copy what I'm doing, learning is like not much. But if you try first and you press pause a lot and you're really trying to learn while you're watching the video rather than just copy, that has greater value. All right, sequences and series, recursive and explicit. So list the first 5 terms of each sequence. So A1 means the first term. Now, for the next one, it says use this formula. So if I want to find the next term, which would be A2, it says, hey, use this. Now this means right here, n-1 means the term before. So if I'm looking here, the term before is -4. So what I'm going to do is I'm going to go -3 times -4 and add 7 and put the answer down. So -3 times -4 is 12. Add 7 and you get 19. And I'm going to follow that pattern again for the next term until I get to 5 terms. So I want to find A3, the third term. So I go back 1 term, that's 19, and I'm going to go that -3 times 19 plus 7. Now I know you don't have a calculator like we do in class at home, so we're going to use Desmos. So press pause and open up Desmos so we can go back and forth. If you have not, you should download Desmos on your phone. It is free, and you're going to use it for so many things, including in college. So it's worth having Desmos on your phone. All right, we're back. So here's Desmos. And I said on Desmos, we're going to go -3 times 19 plus 7. And I get -50. Now we're going to do it again, the same pattern for the next one. But then again, we're going to go -3 times. But now we're going to use the answer we just got. So now it's -3 times -50. Plus 7. That's 157. One more time. Same pattern. We're going to go, and you should try it, right? Press pause and try it. -3 times the answer, 157, plus 7, and you get -464. I'm going to move this to the side. There's my answer. I'm going to do the same thing here for number 2. So for number 2, you're given the first term, you're given the second term, and then to find the third term, we have to use this. Now, we need to understand the first number back is n-1, and the second number back is n-2. So when I look at this, it means go, this one's 2 back, so go 2 back. That's 70, subtract 1 back, which is 30. So I'm going to go 70, take away 30, and then divide by 2. So I'm going to go to Desmos, and I'm going to do that. So 70, take away 30. By the way, if you press the divide button first, or the /, and then go 70, take away 30, and then divide by 2. Now, if I want to find the next term, now I don't use 70. Now I'm using the one that's back, so I want to find this one. So n-1 is this, 20, and then n-2 means 2 back, which is 30. So now I'm going to go 30, take away 20, divided by 2. So again, 30, take away 20, and then divided by 2. And I'm going to follow that pattern. So now if I go 2 back, it's 20. So I'm going to divide 20, take away 5, divided by 2. So okay, 7.5. And then that is 5 terms right there. Here we have a direct formula. So that's the easiest. So to find 1, the first term, A1, wherever there's an n, replace it with 1, and then we're just going to use our calculator to calculate it. So I'm going to type that into Desmos, and I'm going to do it with 2 and do it with 3 and so on. So let me erase these. So I'm going to write 1 cubed then it is subtract parentheses 2 times 1 plus 1 squared. And I get -8. Now I'm going to do the same thing for A2. I'm going to set this up, but instead of 1, wherever I see a 1, I'm just going to type it in with a 2. Same step. So there's a 2. This one will be 2, and the next one will be -17. Change it again. Change this to a 3, and this to a 3, and now the next number in the pattern is -22. You get the idea. Change this to a 4, change this to a 4, and the next number in the pattern is -17. And then the last number, the 5th term, change this to a 5, and you get 4. Those are the first 5 terms. Now this one's kind of fun. So we have a formula. This is called explicit when it's direct like this. So to find the first one, it's 5 times 1. Now in math, this is not an excited number. This is called a factorial. So probably you've never seen it before. So I'm just going to quickly explain what it means. So it means to do a product. So whatever number you see in front of that factorial, it tells you to start with that number and do a product and count down all the way down to 1. So 4 factorial is 4 times 3 times 2 times 1. If I said 3 factorial, you would start with 3 and you would count down and multiply. That's what it means mathematically. We use it a lot in probability, combinations, stats, things like that. So just so you know, in math, if you see an exclamation mark, it means factorial, and that's what it means. Now with our calculator, we're just going to let the calculator do the calculating. So here we have 5 times 1, and then plus, and I'm pretty sure Desmos, if I go 1 and the exclamation on your keyboard, it would know what's happening, and the answer is 6. And then I'm going to keep doing that with all of them. So instead of 1, I'm going to plug in 2. So this is 2, and this is 2. So the next answer is 12. Press pause. See if you can do all the way to 5, and then check your answers. So the next one is 3. And the next one is 4, and then 5. All right, so those are your answers. And that's what it looks like. All right, next one is, do you know the difference between an arithmetic and geometric sequence? So arithmetic, you're adding or subtracting. That's the pattern. The pattern for geometric is multiplying. And how do I know if it's one or the other, or it could be both? So we got to go one at a time. So if there is a common difference here, if I went 5 over 6 subtract 5, what answer would I get? So I'm going to go to Desmos, and I'm going to go 5 over 6, what is it, subtract 5. And that's the answer I get. Now if I take that answer and I go 5 over 6 divided by, I want you to tell you that you're not going to get the same answer at 5 over 36 and so on and so forth. So it's not adding or subtracting. So the other way would be if it was geometric. So for geometric, you take the second number and divide it by the first number and get an answer. Now, if I wanted to, let's see if I can just change this to a fraction. I'm sure there's a way. Not sure. I know there's a way here. Maybe here? No, I'm going to get rid of that. Trying to think if there's a way to change it to see a fraction rather than a decimal in Desmos. All right. So I want to go back here. I'm not quite sure how to make it a fraction answer rather than a decimal answer. So I'm going to tell you right now that this is geometric. And the reason it's geometric is because you are multiplying by 1 over 6. So 5 times 1 over 6, you would multiply the tops and bottoms together. If I took 5 over 6 times 1 over 6, multiply the tops and bottoms together, it would match, it would match, it would match. If I look at number 6, if there was a common difference, I would go negative 16 subtract 1. And then I would take that answer and go negative 16 subtract 17, and it should equal that. It doesn't work. If there is a common ratio, I would go negative 16 divided by 1, which is negative 16. And then I would go negative 16 times negative 16, and it should equal the next one. That's not 81. That doesn't work. So the common difference doesn't work, and the common ratio doesn't work. So it's neither. Number 7, look carefully, press pause, see if you see the pattern. So this pattern is actually positive 7. The numbers are increasing, even though it's hard to tell. So you're adding 7 each time. So this we call is arithmetic. All right, write an explicit rule or recursive formula for what you see. So step number 1 for here is I need to recognize the pattern. What is the pattern here? And if you look really carefully, you're multiplying by 2 to get the next, the next, the next. So it's geometric. So if I'm going to write a recursive formula, I'm first going to say what the first term is. So the first term is negative 7. And then I have a rule where I'm going to take and I'm going to multiply. So then R is this. And I take the term before. So the term before is a, n minus 1, and I multiply it times 2 to get the next, the next, the next. If I need an explicit one, sorry, that goes down here. An explicit one requires the geometric formula. And the geometric formula is a1r to the exponent n minus 1. So in this equation, we're going to go an, a1 again is negative 7, r is 2, and then the exponent is negative 1. So this is explicit, and this is recursive. Look at number 9. And then look carefully to see what type of situation that is. So I know it's hard to tell, but if I go 13 over 6 subtract 3 over 2, and if I get common denominators, that would be 13 subtract 9, which is 4 over 6. And I'm just going to leave that answer as 4 over 6 because we then would have common denominators. So if I go 13 plus 4, and when you add fractions, the denominators stay the same. So if I go 13 plus 4, it actually matches the next, and so on. So this is actually arithmetic. And so for the recursive, we're going to take the term before, which is a, n minus 1, and we're going to add that. It's okay if you don't reduce it down. So 4 over 6. Then for the explicit, we're going to use this formula. We're going to go d, n minus 1 plus a1. So the d, our slope, is 4 over 6. So an equals 4 over 6, and then the first term is 3 over 2. The power of this is if you only know the third or the fourth or the fifth, you can actually adjust this formula for any term in the pattern, not just the first number in the pattern. All right, number 10. What's the pattern? So as I look, I'm going down by 40, then down by 30. It's not arithmetic. So it's not arithmetic. It is a common ratio. I can take any two numbers. So if I take 120 over 160, I could divide by 10. I could also divide by 4 just to reduce it down. So this common ratio is 3/4. So the recursive would take that number 3/4, and you're multiplying the term before. The explicit is using the geometric formula, which is A1, which is 160, R, which is 3 over 4, to the exponent n minus 1. At number 11, look at the pattern, press pause, and see if you see it. This has a common difference of -5. So the recursive will be the term before, which is a n minus 1, and then you subtract 5. We should also write down what A1 equals in the pattern for it to work. So I forgot that. So A1 equals 8. Here for this one, I should write down that A1 equals 160. For this recursive, I should write down A1 equals -7. And for this recursive, I should write down A1 equals 3/2. So for recursive, I need to give you a starting number as well as that recursive formula. Explicit. So again, I'm going to use the formula for arithmetic. So the common difference, and then n minus 1, and then whatever the first term is. All right, write a rule for each sequence, then find it. So for these coming on, we're not going to use recursive. We're just going to use direct formulas. So recognize what type of pattern it is. So if I look carefully, the pattern here is we're adding by 9 every time. So the formula then is arithmetic. So I start with 9, n minus 1, and the first term. To find the 19th, I then plug 19 in for n, and then type that into Desmos. So I want you to press pause and type it in. I'm not going to show you every time when it's something simple. And then see if our answers match. Let's try this again. So look carefully here. I know with decimals, think of money in terms of it. It's going down by the same amount. And if you subtract it with your calculator and see what it is, it's -2.6. So the formula starts with -2.6, then it's n minus 1, and then the first term. To find the 24th term, you plug in 24 for n, and then solve it. So press pause and try it, then come back to the video. Here, I can already tell there's no common difference. There's a ratio here. And then what am I multiplying times? The easiest two numbers to do are actually the last two numbers, 54 divided by 9. And then the formula would be A1, which is 1/4, R, which is 6, to the exponent n minus 1. And then to find the 10th term, we use that formula and a calculator. So go ahead, press pause, and try that first. And it's a big number, 2,519,424. Again, this has a common ratio, and do you notice the signs are alternating? That means the ratio is negative. So if I take -8/3 and divide it by 4, that's like -8/3 times 1/4. So that would give me -8 over 12, or divide by 4 would give me -2/3. So the formula for geometric, A1, which is 4, the common ratio, which is -2/3, to the exponent n minus 1, and then plug in 8 and use your calculator. Now on Desmos, it'll likely give you a decimal. So I'll write that answer as a decimal for you. So as a decimal, and it's okay either form, so -512 divided by 7. So approximately the answer is negative 2.234. Number 16. Use the information given to find the indicated value. So here we're given that it is arithmetic, because we know what d equals, and the 30th term. So I can actually take that, so d, the slope, but instead of n minus 1, I can go n minus 30, and then the 30th term is 213. So right away we have an equation. Plug in 34 into this equation, and you have the answer. And if you did that, try it, and if you did it correctly, see, I got 8 times 4 plus 213, 245. All right, we have two terms, but they're not consecutive. How do I find the common difference? So to find the common difference is like the slope formula that we used back in Math 1, y2 minus y1 and x2 minus x1. In this case, our y values are the answers, so it's going to be negative 16, subtract 28, and the x values are the term numbers, which are 23, take away 1. So the numerator is negative 44, the denominator is 22, so when I divide it, the common difference is negative 2. Number 18. Again, you're given two numbers that are not consecutive. So the step number 1, and this is arithmetic, so that I needed to know that. So I'm going to take the y2 minus y1. Be careful, you're subtracting a negative number, and then 39 take away 1. I'm going to use a calculator here. You can press pause and use a calculator, see what answer you get. All right, that answer is 20. That's not the end answer. I need a formula. So I'm going to go an, I'm going to start with d, the slope, 20, n minus 1, because I do know the first term, and negative 8. And then I'm going to plug in 11 into that formula. So that's 11. So press pause and plug it in. Now press play. Did you get the same answer as me? Again, two terms not consecutive. So again, I'm going to find the common difference. We're going to subtract the tops and the bottoms, and then use our calculator. So go ahead, press pause, and see if you get the same answer as me. I get 4. Then a formula starts with 4, and then n minus 1 plus 13, and then find the 27th term using that formula. Again, press pause. Again, try it first, and see if your answer matches mine. The arithmetic means, so the first number is 16. This tells you how many numbers are missing. So 1, 2, 3, 4, 5, 6. Did I count right? And then the last number is 65. So how do I find the numbers that are missing there? So step 1 is to find the common difference. So the numbers you see are your numerator. So 65 take away 16. Think of this as your first term, and then count all the way across to see how many terms there are. So 1, 2, 3, 4, 5, 6, 7, 8. So for the denominator, you're going to go 8 take away 1, and then use your calculator. So you should press pause and try it. I'm typing it in Desmos right now on another screen, and I get the common difference to be 7. So then I know what I'm adding or subtracting to find the missing number. So 16 plus 7, 23 plus 7, and so you keep adding 7 all the way across. And you know if you did it right, if the last number, if I add 7, which it does, it should equal the last number. Fractions. I'm going to use this as a decimal. So instead of 91 divided, use my calculator, that's 9.1. I'm missing 4 numbers. And then 48 divided by 5. I'm going to do that. So 48 divided by 5, 9.6. So now I have the numbers and trying to figure out what's in the middle. So to find the common difference, take 9.6, take away 9.1. And then how many terms do I have? So A1, 2, 3, 4, 5, 6. So I'm going to go 6, take away 1, and then use my calculator. It's going to be a decimal answer. So I'm going to go 9.6 subtract 9.1. I get 0.1 as my answer. So it's like adding a dime, or 0.1. So this is 9.2. Keep adding 0.1. And notice if you add 0.1, it equals what the answer is at the end. All right, turn the page. Number 22. Use the information given to find the indicated value. So now it's geometric. So we know we need a formula. So A1 is 3. Our base, is -6 to the exponent n minus 1. And then plug in 7 and then solve it. So again, use your calculator. Press pause and try it first and know that you can do this. That's 139,968. Here, we can adjust the formula, also with geometric. So instead of the first term, the fifth term is 1/4. The base is -1/2. And instead of n minus 1, we can go n minus 5. So the fifth term is 1/4. It's still the same formula. So to find a 8, just plug 8 into that formula. And let me do that too. So try it or press pause. And I get -0.03125. All right, number 24. Here you're given 2, and you don't know the ratio. So I'm going to help you through this the easiest way possible. You ready? So there's a little, I think this is going to be helpful. We're going to divide these two numbers. We're going to go -48 divided by -6. And then in the exponent is going to be a fractional exponent, a radical. And it's always going to be 1 over, and then you're going to subtract the term number. So 5 take away 2. And this is what you're going to type into Desmos. So if I showed you Desmos, because I'm trying to be nice here. So -48 divided by -6. Divided by 6. No, -48 divided by -6. And then to the exponent, and it's going to be a fraction. Now, it's 1/3, and so the common ratio is 2. We're not done yet. So now we need a formula. So we're going to start with A2, because that's what we have. So we're going to be -6. The base is 2, and then the exponent isn't going to be n minus 1. I know it's a little blurry. But because it's the second term that we're using, it's going to be n minus 2. And then we plug in the term number we're looking for, which is 7. So it's -6, 2, and then 7 take away 2, and then solve it. Typing it in. You should get -192. Make sure. Yeah. All right, 25. We're going to do the same thing again. I know it's a little tricky, so we're going to do it together. So R equals. So what we're going to do is divide. So -5 over 27 divided by -5. And then in the exponent, it's going to be 1 over, and we're going to subtract these. 4, take away 1. And then we're going to use Desmos to find what r equals by doing that. Now, r is going to be a fraction when I do this. It's going to be 1 negative a third. Or is it positive a third? It's a negative divided by negative, so it's positive 1/3. But if I use Desmos, it's okay to use a decimal. So if I did Desmos, what it would look like, it would be negative 5 over 27 divided by negative 5 to the exponent one-third. Oh, why is it not doing an exponent? There it is. So it's 0.3 repeating. 0.3 repeating is the same as a third. It's fine. 0.3. And then to find A6, we need a formula. So A1 is negative 5. The R we're going to just call 0.3 to the n minus 1. And then we're going to plug in 6 and get our answer. So I'm typing it into Desmos. You should do it too. You should press pause. Make sure you know how to do it. And I get negative 0.0125. Negative 0.01215. This is what it looks like. Number 26. Find the indicated arithmetic means. So I'm going to tell you that that's a typo. This word should be the word geometric. So we're going to go and we're going to have 3 numbers that are missing and then 48. So we're going to take the last number divided by the first and go 1 over and subtract. So this is A1, 2, 3, 4, 5. So there's 5 terms. So I'm going to go 5, take away 1, and I'm going to type that into Desmos. So press pause, type this into Desmos, and get an answer. That answer is 2, and then this is what we're multiplying times to get the next. So it's 3 times 2 times 2 times 2, and then times 2. So the arithmetic means are those numbers in the middle that are missing. All right, 4 divided by 81. Silliness. So we're going to go 4 of 81 divided by 12. And then there are 4 numbers that are missing. That means in this pattern there are 6 numbers. So I'm going to go 6 take away 1, which is 5. And then I'm going to type that in and then find the numbers that are missing in terms of it. I'm going to do some calculating here. So I'm just going to help you out. That number, when you do it, is 1/3, and that's what you're going to multiply over and over and over again. So 12 times a third, 4 times a third, and then 4/3 times a third. and then 4 over 9 times a third, times 3 and times 1, and then you could see that if you multiply it times 1/3, that matches. That was tricky. Don't get frustrated by that one. Number 28, find that sum. How do I add it? So first I need to recognize what kind of pattern it is. So this one is a arithmetic pattern. Sometimes it's easier to get common denominators. So we have negative 53 over 10, subtract. Now I'm going to get common denominators by multiplying times 2. Remember, when you subtract a negative, it is like adding. So negative 53 plus 38. That is 15 over 10, negative 15 over 10. Or divide by 5, negative 3 over 2. So the formula to add this up, I need to know the first number, I need to know the last number, and how many numbers I have. So I don't know the last one. So I need a formula to find the last number in the pattern. So I'm going to take d, n minus 1, and minus 19 over 5, and then I'm going to look for the last number in the pattern, which is 18. These are obnoxious numbers that won't be on the exam, just to let you know. So I'm going to help you through it. So if we did this, that's negative 293 over 10, and then the formula. So I'm adding 18 numbers. So I'm going to start with the first number plus the last number. When you add a negative, it's negative. And then multiply by how many you have, divided by 2. I'm just going to give you the answer. So as a decimal, it's negative 297.9. And I know those numbers are difficult to work with. 29 is way nicer. In 29, you can see the pattern is not arithmetic, and especially if you look at the last two, I want you to see you're dividing by 3, or you could see the common ratio is 1/3. To add this up, I have 7 numbers I'm adding. I have a fraction. The first term, A1, and then 1 subtract the common ratio to the exponent, how many numbers you have, and then in the denominator is 1 subtract a third. So especially with your calculator, I'm going to remind you how to use your parentheses to be able to type that in correctly. So let's look here and let's do it together. So go to Desmos. You're going to start with the parentheses, and you're going to type in negative 405 parentheses 1 subtract parentheses for 1/3 to the exponent 7, and then you're going to close with 2 parentheses. Oops, move the cursor. Close with 2, and then divide, and then another parentheses, 1 subtract a third. Every time you have a fraction or a negative number, they need their own parentheses. And you have your answer. And we're going to round that. So that's negative 607.2. That's fine. Okay, number 30. I need to recognize in number 30 that 11 subtract 8p is linear. That means the exponent on the letter is 1, and it's a linear pattern, which means it's arithmetic. The other one would be if it's exponential and the variable's in the exponent. Those are your options. So is it exponential or linear? It's not exponential, it's linear. So I need to know the first term. So I need to plug in 1. So 11 take away 8 times 1. That's 3. Then I need to plug in 14. So it's 11 take away 8 times 14. That's negative 101. And then the formula to add them up. So there's 14 numbers from 1 to 14. So we take the first and the last and combine them together, negative 101. And then how many do I have? Divided by 2. This could also be in front, 14 divided by 2, and then that. And then put it in the calculator, and you get negative 686. This one is geometric because it's exponential. The variable's in the exponent. I still need to know A1. So I got to go -5, 1/2, and then it's 1 take away 1. If you type that in a calculator, the answer is -5. So I'm now going to add up 1 through 7 is 7 numbers. Big fraction. We start with A1 and then 1 subtract. The base is our R to the exponent 7. And then in the denominator would be 1 subtract 1/2. So make sure we're typing it in correctly. Use your calculator, press pause. This is the answer. As a decimal, the answer would be -9.92187, like that, 875. All right, last page. Is this an exponential or a linear? Those are your options. You can see it's in the exponent, so I need to know A1. Now, for this one, to find the first term, the number we plug in is 2. So it's 3, then -4 to the exponent 2, take away 1. And then use your calculator. Then you set up the formula. So that's all I needed for the formula. Now, this part's a little tricky. To know how many terms there are, you take the top number, subtract the bottom number, and then add 1. That's how many numbers there are. So 9 take away 2, plus 1 means there's 8. So we start with A1, 1 minus the base. Because it's negative, it needs its own parentheses. Take a moment, pause, press it, put this in the calculator so you know you can do it, and then write down the answer. So 157,284. 33. So to find the first term, I plug in 4. So it's 1/2 times 4, subtract 7/6. I'll help you through this. Again, kind of silly numbers to use, but times 6, top and bottom. And then common denominators, that's 5/6. I needed that. I also need to know the last number, which is 13. So it's 1/2 times 13. Take away 7/6. Again, totally obnoxious. We're going to multiply times 3, top and bottom, so I get common denominators. 39 take away 7 is 32/6. I'm going to let that go. And then to add up the first. Now, to know how many terms there are, you take 13, take away 4, and add 1. So that is 10. So I go the first number, which is 5/6, the last number, which is 32/6, and then multiply by how many numbers you have, divided by 2. So if you use your calculator, go ahead and use your calculator. Use Desmos. You would get a decimal, and I got 30.83 repeating. All right, notice this goes to infinity. I want you to know R is the base. Since 7 divided by 5, take your calculator, go 7 divided by 5, you can see that that answer is 1.4. Since that number is greater than 1, this has no sum. And the word that we use is divergent, or it diverges. In order for there to be an infinite sum, R has to be between -1 and 1. Notice this R, 3/4, even if you changed it to a decimal, is it between -1 and 1? 0.75. Is it in between those two numbers? Yes, so there's an infinite sum. The formula is A1. So if you plug in 1 for x, 1 take away 1 is 0. So 3/4 to the 0, put that. So if you put this in your calculator, type that in your calculator, press pause, you would get this answer. And then it's 1 subtract the base, or the R, which is 3/4. Go ahead, type that in your calculator with parentheses. And you get see. Let me do it. And you get the answer 6. Oops. All right, a few stories and then we're done. Whenever you have a story, just break it down as a pattern. In 2004, the moose population in a certain area, I feel this might be in Canada, which I really like. Since then, the population has decreased by 6% each year. In which year will the population be dropped below 1,000? Oh, this one's going to be not so fun, but we're going to do it together. So first of all, to find the rate, if it's decreasing by 1%, we go 1 subtract whatever that percent is as a decimal. So there is our R. So 1 take away 6% as a decimal and put it together. The pattern for a geometric we know is this. So when will it drop below 1,000? So here the end answer is 1,000. A1 we have 1,700 moose. And we're trying to figure this out in terms of when will this be 1,000, and we're going to solve it. So we're going to divide by 1,700. It's okay. Then to solve it, we have to write it as a logarithm. So it's an exponential equation. To solve an exponential equation, we use a logarithm. So write down the exponent, which is n minus 1. The logarithm has a base of 0.94. And then inside the logarithm is 1,000 divided by 1,700. To this, we're going to add 1 to both sides. And then I'm going to go to my calculator. So that's what I'm going to type in the calculator. So I'm going to remind you, how do you type a logarithm into the calculator? So first type in log. And then we first type in what's inside the logarithm. That's 1,000 divided by 1,700. And then we divide, and we do another log, and with the base, which is 0.94. And then we're going to add 1. And we're going to round up to what that date would be. So what year will it drop below 1,000? And the answer is in 10 years. If we round it, so if we add 10 to the year that we see there, so if I add 10 to the year I see, it would be in the year 2014. All right, there is no question on the exam that involves a logarithm, so I'm sorry that happened. Janet was hired as a lifeguard with a starting wage of $6.25. That's A1. She receives 80-cent raise annually. That's going to be your common difference. You're going to add 80 cents every year. How long will it take for her salary to double? So to understand the pattern, I need a formula. So the common difference, n minus 1 plus $6.25. So we have our common difference, n minus 1 is $6.25. And I want to know when this will double. So if you double $6.25, and then I want to solve this. So I'm going to subtract $6.25. See if I can do that. Oh, that's $6.25. Obviously, divide by 80 cents. How many 80 cents are in 625? Oh, let's see if it's even. Probably is, and I'm not thinking. I'm just using Desmos. It's not even. 7.8125. Add 1 to that answer, and we're going to round. So if you add 1, it's 8.8125. And if I round up, how long will it take? We're going to say 9 years. So in 9 years, her salary will double. Last one, we got there. Number 38. Eric ran 4.1 miles the first day, 4.5 the next day, 4.9 the third day. If the pattern continues, find the total mileage after 45 days. So, what is this pattern? I can see there's a common difference of 0.4. That's what I'm adding every time. So to add up 45 days, we're going to take the first number, which is 4.1. I need a formula to find the last day, the 45th day. So the common difference, n minus 1 plus 4.1, and then the last day is 45. So I'm going to plug in 45 and see how many miles did he run on the 45th day, and use my calculator. And that's 21.7. I'm going to add the first day and the last day, and then I'm going to multiply by how many days divided by 2. And then again, I'm going to use my calculator. So press pause. And so the total mileage after 45 days is, excuse my writing, 580.5 miles. We got it. It's over. All right, Mr. G Math over and out. I hope that helped. I really want you to pass that exam. You need to know that that you have a great math teacher in Miss Perez. Just want you to know that. And those that have me, I think you have a good math teacher too. And those that have Miss Villanueva, you have a great math teacher. You guys are so lucky. All right, till next time.